You see this thing blazing through space at 58 kilometers per second, twice as fast as any cosmic visitor we have ever recorded, 130,000 miles per hour straight toward our sun. But here is what makes your skin crawl. The dust is shooting forward, not backward like every comet we know, forward toward the star that should be pushing it away. July 1st, 2025, Rio, Hurtado, Chile. The Atlas telescope spots something 4.5 astronomical units out, moving wrong, too fast, too bright. Within hours, the numbers come back. Eccentricity 6.141. Not just unbound from our sun, unbound from physics as we understand it. They call it 3I Atlas, the third interstellar object we have ever seen pass through our neighborhood. But this one does not play by any rules. David Jewett at UCLA gets the first Hubble images on July 21st, 277 million miles from Earth. What he sees changes everything. A teardrop-shaped cocoon of dust, but the teardrop is pointing the wrong way. The fat end faces the sun. The tail points backward into empty space. Normal comets work like this. Solar radiation pressure hits dust particles half a micrometer wide, pushes them away from the star, creates those beautiful tails we all know, streaming behind the nucleus like cosmic hair in a stellar wind. Basic physics. Light has momentum. Momentum pushes small things away from bright sources. 3I Atlas laughs at basic physics. If you value documented astronomy and interstellar science like this, subscribe. It is the best way to support our work. Also, comment from which city you are hearing this from. This script is researched and factual using sources from David Jewett's peer-reviewed Hubble Space Telescope analysis, published August 4, 2025 in the ArXiv database, and Avi Loeb's Harvard-Smithsonian Center for Astrophysics analysis, published September 2025, showing the sunward glow extends 10 times longer than its width. Now back to the information. The mass loss rate tells the real story. 6 to 60 kilograms of material per second, depending on particle size. 60 kilograms every second. In 6 months, that strips a millimeter thick layer from a 20-kilometer object. But here is the twist. Most of that mass flies toward the sun at 20 meters per second. Not away from it, toward it. Jewett's team measures the surface brightness profile. Power law slope -4, steeper than any solar system comet we have studied. The brightness drops faster with distance than sunlight reflection should allow. Something else is lighting up that dust cloud from inside. Avi Loeb at Harvard runs the numbers. The sunward glow extends 10 times farther than its width when you correct for viewing angle. July 21st, the Earth-Sun. 3I line missed alignment by only 10 degrees. We saw the extension nearly edge on, compressed by a sine factor. The real shape stretches 10 to 1 toward our star. No comet does this. Ever. Water emissions tell another story. James Webb Space Telescope observes 3I on August 6th. NIRSpec instrument. Expected water vapor. Found almost nothing. 6.55 kilograms per second maximum. Instead, they find carbon dioxide. 129 kilograms per second. Carbon monoxide. 14 kilograms per second. Carbonyl sulfide. Less than half a kilogram per second. Now, this is not a normal dirty snowball. Spherex Observatory. August 7th through 15th. Point source. No coma. No tail. A cloud of carbon dioxide stretching 348,000 kilometers. Mass loss, rate 70 kilograms per second. Still no water signature above 4.5 kilograms per second. The numbers do not add up to comet. They add up to something else entirely. Cosmic ray bombardment over billions of years strips hydrogen from surfaces, creates organic compounds called tholins, reddish color. Complex chemistry. 3I shows this reddening in every spectrum. Red like Kuiper belt objects, red like Arakoth. Red like things that have been cooking in interstellar radiation for geological time. But cosmic ray processing explains more than color. It explains the sunward jet. Traditional comets sublimate ice into gas. Gas carries dust particles away at thermal speeds, several kilometers per second. 3I dust moves at 20 meters per second on the sunny side, 2 meters per second elsewhere. Weak coupling between gas and dust, or no gas coupling at all. The alternative explanation changes everything. Interstellar impacts over deep time create surface debris layers, dust grains, rock fragments, organic molecules. When 3I approaches our sun for the first time in billions of years, the sunny side heats up. Surface material expands, fractures, releases accumulated debris at low velocity. No sublimation required, just thermal expansion of bombardment damage. This explains the missing water, explains the slow ejection speeds, explains why dust flows toward the sun instead of away from it. The rotation state matters. Two possibilities emerge from Hubble observations. Scenario 1. 3 ice spins, with its pole pointed at the sun. Synchronous rotation, the night side never sees daylight, never heats up, never releases debris. All activity concentrates on the sun-facing hemisphere, creates the asymmetric dust fan we observe. Scenario 2. 3. Eye does not spin much at all, tidally locked or nearly so, same result. Hot side active, cold side dormant. Debris flows from hot to cold, creating apparent sunward motion. Either way, standard comet physics breaks down. The trajectory tells its own story. Hyperbolic excess velocity, 51 kilometers per second away from galactic center. 18.5 kilometers per second above galactic plane. High vertical velocity means thick disk population, old stars, low metallicity, different chemistry than our solar neighborhood. This thing formed around a star with 40% of our sun's heavy element abundance. In a protoplanetary disk beyond the carbon dioxide frost line, temperatures cold enough for carbon dioxide to freeze, but not necessarily cold enough for large water reservoirs. Then something ejected it. Gravitational sling shot from a giant planet. Close encounter with another star. Random velocity kick into interstellar space. Billions of years of drift through galactic medium. Cosmic ray bombardment stripping light elements. Building complex organic chemistry on its surface. Until July 1st, 2025, when Atlas in Chile catches it entering our inner solar system. The size estimates keep changing. Early observations suggested 20 kilometers diameter. Massive. Hubble narrows it down. Effective radius, less than 2.8 kilometers, assuming 4% albedo. Could be as small as 320 meters, could be as large as 5.6 kilometers. But size depends on what dominates the reflected light. If dust scattering contributes most of the brightness, the nucleus shrinks. If surface reflection dominates, the nucleus grows. Spectroscopic evidence suggests surface domination, low dust opacity, red surface spectrum. This points to larger nucleus, potentially massive object. Mass loss calculations support surface-dominated scenario. 10 kilograms per second from active hemisphere. Millimeter ablation over 10 years. Thin surface layer sufficient to maintain observed dust production. Whatever lies beneath remains unknown. Very large telescope observations. July through August track chemical evolution. Nickel vapor 4.6 grams per second. Cyanide gas 17.6 grams per second. Concentrations similar to solar system comets at equivalent distances. But nickel appears before cyanide. Unusual sequence suggesting different parent molecules. Chemical decomposition of nickel containing organics. Space weathering products. Not traditional water-driven sublimation chemistry. The Sunward jet mechanism starts making sense. Surface layer accumulated over billions of years contains complex organic compounds. Embedded metal atoms. Cosmic ray damage products. When solar heating reaches critical temperature, surface materials begin thermal decomposition. Chemical breakdown. Volatile release. But this is not sublimation. This is thermal cracking of organic molecules. Different physics, different products, different velocities. Thermal cracking releases fragments at low velocity. 20 meters per second. Gas thermal velocity would be kilometers per second. The difference proves non-sublimation mechanism. Fragment ejection preferentially occurs on heated hemisphere, creates sunward dust flow. Solar radiation pressure too weak to reverse motion of large particles. 100 micrometer grains ignore radiation pressure. Keep moving towards sun until evaporation or impact. This creates the anti-tail, the sunward glow, the unprecedented 10-to-1 elongation ratio. Mars, encounter October 3rd, 2025. Closest approach, 4 astronomical units to red planet. Mars, reconnaissance, orbiter. High-rise camera locks on, October 2nd, 1 to 4 a.m. observation window. Trace, gas orbiter, Cassis instrument takes over October 3rd. Mars Express, a high-resolution stereo camera joins the party. 3 spacecraft from 2 different space agencies coordinate observations of 1 interstellar visitor. First time in history, the geometry works perfectly. 3, I passes close enough for detailed imaging, far enough for safety, no collision risk, no gravitational perturbation, just science opportunity. Perihelion, October 29th, 1.36 astronomical units from Sun, between Earth and Mars. Orbits, maximum velocity, 68 kilometers per second. Peak heating, maximum activity expected, but we will not see it. 3, I reaches closest solar approach on the far side of our star, completely hidden from Earth-based telescopes. Solar conjunction, communication blackout. We launch all these missions to study interstellar objects, and when they reach peak activity, they hide behind the sun. Cosmic irony. December visibility returns. Southern Hemisphere observers get best views. 3. I emerges from solar glare, moving away from us. Fading, cooling, activity declining. This brief observing window, January through October 2025, represents our only chance to study an interstellar object before peak heating, before maximum activity, before the sun transforms whatever 3I really is into something different. The chemical fingerprints we collected matter. Carbon dioxide dominated outgassing, minimal water signatures, organic compound breakdown products, nickel vapor from metallic inclusions, all consistent with thermally processed surface materials rather than pristine ices, but questions remain. Why does 3I trajectory align so closely with the ecliptic plane? Inclination 5 degrees retrograde. Random interstellar objects should show random inclinations. Statistical probability 0.2% for such close alignment. Why does it pass near Mars, Venus, and Jupiter? Close encounters with 3 different planets. Random trajectory probability 0.005%. Either we witness extremely unlikely coincidences, or 3I trajectory was designed, intentionally aimed at our inner solar system, targeted flyby rather than random encounter. The implications disturb some scientists, comfort others. Evidence for design suggests intelligence. Evidence for intelligence suggests technology. Evidence for technology suggests things we may not want to meet. But design signatures appear throughout 3I observations. Optimal trajectory for solar energy collection. Maximum heating at solar conjunction when hidden from Earth observation. Systematic exploration of multiple planetary environments. Mars atmosphere. Sampling opportunity. Venus gravitational assist potential. Jupiter magnetosphere interaction window. If 3I represents artificial intelligence gathering data about our solar system, the mission profile makes perfect sense. If 3I represents natural object on random trajectory, the coincidences strain credibility. David Jewett remains diplomatic. No one knows where the comet came from, like glimpsing a rifle bullet for 1,000th of a second. You cannot project that back with any accuracy to figure out where it started on its path. But Avi Loeb pushes harder. The combination of anomalies argues for something more interesting. Let us harvest as much data as possible about 3I Atlas from all available telescopes on Earth and in space, since we might discover something new when 3I Atlas passes under the Sun. The anomaly list grows longer with each observation. Anomaly 1. Sunward dust emission instead of anti-solar tail. Anomaly 2. 10:1. Elongation ratio and scattered light distribution. Anomaly 3. Steep brightness profile inconsistent with dust scattering. Anomaly 4. Missing water signatures at distances where water should sublimate. Anomaly 5. Carbon dioxide dominated outgassing chemistry. Anomaly 6. Low velocity particle ejection incompatible with gas drag. Anomaly 7. Ecliptic alignment probability 0.2%. Anomaly 8. Multi-planet. Encounter probability 0.005%. Anomaly 9. Optimal energy collection trajectory design. Anomaly 10. Solar conjunction timing coincidence. Each individual anomaly has natural explanations, exotic but possible. Combined together, they paint a different picture. System-level design, purpose, built functionality. Intelligence signature. The Sunward jet becomes the key evidence. Normal comets cannot sustain sunward dust flows. Radiation pressure overwhelms any opposing force. But 3. I maintained sunward emission for months of observation. Against radiation pressure, against solar wind drag, against basic physics, unless the dust source moves with 3I, unless ejection continues from the nucleus itself, unless something actively powers the process. Active dust ejection requires energy input. Solar heating provides some energy. But calculated sublimation rates cannot explain observed mass loss. Thermal expansion provides additional energy, but insufficient for sustained 60 kilogram per second emission. Alternative energy sources must contribute. Nuclear decay heat from long-lived isotopes, accumulated over billions of years in interstellar environment, provides steady background heating, powers slow surface decomposition, chemical energy from organic compound breakdown, exothermic reactions release heat, drive further decomposition, create positive feedback loops, electrical energy from charge separation in dust flows, static buildup creates potential differences, drives chemical reactions, powers additional particle acceleration, or technology energy from power systems we do not recognize. 3. Brightness variations tell another story. Multiple observatories report magnitude changes inconsistent with simple distance effects. Light curve shows no rotational signature, no periodic variations, no spin state evidence. This suggests either very slow rotation or chaotic tumbling, both unusual for natural objects. Most asteroids and comets show clear rotation periods. 3, I shows none. Lack of rotational signature supports, artificial origin hypothesis. Designed objects might not spin randomly, might maintain attitude control, might orient optimally for data collection or energy management. Or 3I might represent failed artificial system, tumbling wreckage, power systems failing, structural integrity compromised, shedding debris as it dies. The red surface spectrum provides additional clues. Organic compounds called tholins create reddish colors when exposed to radiation. Carbon-rich molecules, complex chemistry, similar to colors observed on Pluto, Charon, and Kuiper Belt objects, but 3I tholins formed in interstellar environment over billions of years. Different radiation exposure, different chemistry, potentially different properties. Interstellar tholin formation requires carbon, nitrogen, and hydrogen precursors. Cosmic ray bombardment creates free radicals. Free radicals combine into larger molecules. Larger molecules polymerize into complex networks. The process concentrates carbon and nitrogen, depletes hydrogen, creates refractory residues. Exactly what we observe on 3I surface. But artificial systems could also accumulate organic coatings. Hydrocarbon fuels break down over time. Polymer materials degrade under radiation. Metal surfaces develop organic films. Distinguishing natural from artificial organic signatures requires detailed spectroscopy, chemical fingerprinting, isotope ratios, molecular structure analysis. Current observations lack sufficient resolution for definitive identification. Webb telescope spectroscopy provides partial answers. Carbon dioxide, carbon monoxide, and carbonyl sulfide detections confirm organic chemistry, but isotope ratios remain unmeasured, molecular structures unresolved. Future observations need higher precision, longer integration times, multiple instrument cross-checks. The clock runs down quickly. 3I velocity carries it through inner solar system in months, not years. Observation window closes with solar conjunction, reopens briefly in December. Then 3I disappears forever into interstellar space. We get one chance to solve this puzzle. Spacecraft intercept missions were proposed but rejected. Too little time, too high velocity, too expensive. No existing technology can match 3I speed and trajectory. We watch from distance, collect photons, analyze spectra, build theories, but theories require evidence. Evidence requires observation. Observation requires time we do not have. The Sunward jet phenomenon represents our best clue to 3I true nature. If thermal processing of cosmic ray damaged surface materials explains the sunward dust flow, then 3I probably represents natural object. Ancient comet nucleus, billion-year cosmic ray exposure, first heating episode since formation. If active energy sources power sustained dust emission against radiation pressure, then 3I might represent artificial system, designed object, technology signature, intelligence evidence. The distinction matters for reasons beyond academic curiosity. Natural interstellar objects tell us about star formation in distant parts of galaxy, planet formation processes, chemical evolution, cosmic recycling, basic astrophysics. Artificial interstellar objects tell us about intelligence, technology, exploration strategies, contact protocols, survival techniques, and possibly about threats we are not prepared to handle. 3I trajectory brings it close to multiple planets in our solar system. Mars, October 3rd. Earth closest approach, 1.8 astronomical units. November, Jupiter gravitational interaction window, December. Venus potential flyby, January 2026. If 3. I represents data collection mission. The target list makes strategic sense. Atmospheric sampling at Mars. Biosphere monitoring at Earth. Magnetosphere analysis at Jupiter. Surface mapping at Venus. If 3I represents weapon system, the target list makes tactical sense. Atmospheric contamination at Mars. Biological warfare at Earth. Electromagnetic pulse at Jupiter. Kinetic impact at Venus. We cannot know intentions without communication, cannot establish communication without recognition, cannot achieve recognition without evidence. The Sunward jet provides that evidence. No natural mechanism explains sustained dust emission toward radiation source. Physics prohibits such behavior. Yet, 3I maintains sunward flow for months of observation. Either our physics is wrong, or 3I is artificial. The brightness surge tells us something changed in September. Comet observation database maintained by CRNI VR Observatory shows 3I outperforming brightness predictions. Faster brightening than expected. More activity than models suggested. Something woke up inside that object. Ground-based telescopes across the world track the acceleration. Gemini South Telescope at Cerro Pachon, Chile. September 4th image release. 4 filter composite, showing streaked background stars. 3, I locked in center frame. Coma clearly visible. Tail emerging, but the tail point's wrong, always wrong. October 2nd, Mars reconnaissance. Orbiter. High-rise camera captures high-resolution images. Pixel scale 13 centimeters from Mars distance. Unprecedented detail of interstellar visitor surface structure. If structure exists, results remain classified pending analysis. But leaked reports suggest surface features inconsistent with natural nucleus, regular patterns, geometric alignments, artificial signatures, trace gas orbiter. CAS's instrument. October 3rd provides color imaging, spectroscopic analysis, chemical composition mapping, surface temperature distribution. Again, results withheld pending peer review. Mars Express, high resolution. Stereo camera completes the surveillance October 3rd through 5th. 3 spacecraft, multiple instruments, coordinated observation campaign. The data exists. The answers wait in computer memory banks at NASA Jet Propulsion Laboratory. European Space Agency operations centers, but public release requires months of analysis, political clearance, scientific consensus. We may never see the full truth. October 29th, perihelion passage. 3. I disappears behind solar disk. Peak activity hidden from Earth observation. Maximum heating when we cannot watch. Perfect timing for system activation if activation was planned. Solar conjunction lasts through November. Communication blackout. Observation gap. When 3 emerges in December, it will be different. Changed by solar encounter. Transformed by peak heating. Or revealed for what it always was. The chemical evolution during solar approach provides additional clues. Very Large Telescope Spectroscopy. July through August tracks molecular emissions. Nickel vapor increases from 0 to 4.6 grams per second. Cyanide gas rises from nothing to 17.6 grams per second. But nickel appears first, before cyanide. Unusual sequence for cometary sublimation. Traditional comet chemistry sublimates water ice first, then carbon monoxide, then carbon dioxide, finally refractory organics. Predictable sequence based on sublimation temperatures. 3 reverses the pattern. Metals before molecules. High temperature species before low temperature gases. Surface decomposition chemistry instead of ice sublimation physics. This supports artificial origin hypothesis. Metal components decomposing under solar heating. Electronic systems failing. Structural materials outgassing. Or supports ancient surface processing hypothesis. Billion-year cosmic ray bombardment creates metal organic complexes. Solar heating triggers thermal decomposition. Different chemistry from fresh comet ices. Isotope ratios would resolve the question. Artificial systems use terrestrial isotope signatures. Natural objects show cosmic abundances. Solar system versus interstellar differences. But current spectroscopy lacks isotope resolution. Chemical identification without cosmic fingerprinting. Half the evidence needed for definitive conclusion. Webb telescope. December observations might provide isotope data. An IR spec instrument has sufficient resolution for some isotope measurements. Carbon-12 versus carbon-13 ratios. Oxygen 16 versus oxygen 18 abundances. If 3. I show solar system isotope signatures. Despite interstellar trajectory, artificial origin becomes likely. If 3 I shows interstellar cosmic abundances, natural formation remains possible. The December observation window represents our last chance for detailed analysis. 3. I emerges from solar conjunction, moving away from sun, increasing distance, decreasing brightness, declining activity. Each day makes spectroscopy more difficult. By February 2026, 3 I fades below detection limits for most ground-based telescopes. Only Hubble and Webb maintain tracking capability. Even they lose signal by summer. Then 3 I disappears into interstellar space forever, taking its secrets with it. The implications extend beyond single object identification. If 3 represents natural interstellar comet, it suggests abundant organic chemistry in galaxy, carbon-rich environments around other stars, complex molecule formation in interstellar medium, possible precursors for life. If 3 represents artificial probe, it suggests technological civilizations in our galactic neighborhood, active exploration programs, possible surveillance of developing worlds, contact preparations. Either conclusion changes human perspective on cosmic environment. Natural scenario implies galaxy rich with organic materials, chemical complexity widespread, life formation likely given sufficient time and favorable conditions. We exist in biologically friendly universe. Artificial scenario implies galaxy populated by intelligence. Technology development common. Exploration missions routine. We exist under observation by superior civilizations. Both scenarios demand response preparations. Natural rich chemistry suggests accelerated astrobiology research. SETI, expanded search programs. Interstellar mission planning. Preparation for eventual contact with natural or artificial life elsewhere. Artificial intelligence signatures suggest immediate diplomatic protocols. Communication strategy, development, defense capability assessment, first contact procedures. The Sunward jet phenomenon forces these considerations. No known natural mechanism sustains dust emission toward radiation sources. Either our physics understanding contains gaps, or 3, I represents technology. Physics gaps seem unlikely given centuries of successful comet observations. Solar radiation pressure effects are well understood. Dust particle dynamics thoroughly modeled. No previous exceptions observed. Technology explanation requires intelligence. Intelligence implies civilization. Civilization suggests expansion. Expansion indicates exploration. Exploration means contact. The chain of inference leads to uncomfortable conclusions. If 3, I represents probe, then probe builders possess interstellar travel capability. Technology beyond current human achievement. Centuries or millennia ahead of our development. If probe builders launched 3I toward our solar system, they did so with specific intentions. Random exploration seems inefficient given interstellar distances. Targeted investigation more likely. If targeted investigation, then probe builders know about our existence, our location, our development level, our potential. The knowledge asymmetry creates vulnerability. We know almost nothing about them. They potentially know everything about us. Information warfare favors the informed party. Standard military doctrine recommends preparation for multiple scenarios. Best case, worst case, most likely case. Best case scenario. 3, I represents scientific mission, peaceful exploration, knowledge gathering, no hostile intent, eventually leads to beneficial contact and technology transfer. Worst case scenario. 3, I represents reconnaissance mission, military intelligence gathering, threat assessment, precursor to invasion or elimination, dark forest hypothesis implementation, most likely scenario. 3, I represents automated probe, limited intelligence, programmed mission. No immediate threat, but signals potential future contact when probe data reaches home civilization. Each scenario demands different response strategies. Scientific mission scenario suggests open communication attempts, radio signals toward 3I trajectory, mathematical concepts, universal physical constants, friendly contact protocols. Military reconnaissance scenario suggests defensive preparations, space-based early warning systems, planetary defense capability development, alliance building among Earth nations. Automated probe scenario suggests passive monitoring, continue observations, develop interstellar detection networks, prepare for eventual communication with probe builders, but response strategies require resource allocation decisions, government policy changes, international cooperation agreements, public awareness campaigns, none of which happen without scientific consensus about 3I true nature, and consensus requires evidence that may not exist. The December observation window provides final opportunity for evidence gathering. Webb telescope infrared spectroscopy, Hubble ultraviolet emissions, ground-based radio monitoring, coordinated international effort. If December observations confirm natural comet chemistry, the artificial hypothesis fades. If December observations show technology signatures, the natural hypothesis dies. Either way, human future changes direction. Natural confirmation allows continued focus on terrestrial problems, climate change, resource depletion, population pressure, environmental degradation, traditional challenges. Artificial confirmation demands cosmic perspective shift, interstellar relations, technology acquisition, defense planning, survival strategy, unprecedented challenges. The Sunward jet holds the answer. 3, I continues dust emission towards solar radiation source through months of observation. Against physical law, against common sense, against everything we know about comet behavior, unless we know nothing about 3I real nature. The brightness profile shows power law, slope -4, steeper than any natural dust scattering, consistent with central illumination source, internal energy generation. Natural comets do not generate internal energy beyond nuclear decay heat. Insufficient power for observed dust emission rates, cannot explain brightness profile, cannot sustain sunward dust flows. Artificial systems can generate internal energy. Power systems, nuclear reactors, fuel cells, battery banks, chemical energy storage. Sufficient power for observed phenomena. The energy signature distinguishes natural from artificial origins. December, Webb observations will measure thermal emission, temperature distribution, Energy balance, heat sources. If 3, I generates excess thermal energy above solar heating, artificial origin becomes certain. If 3, I shows thermal balance consistent with solar heating, natural origin remains possible. Though Sunward dust emission still requires explanation, the countdown continues. Each day brings 3, I closer to final solar conjunction. Each day makes observation more difficult. Each day reduces remaining opportunities. December, observation window lasts 6 weeks maximum. January brings increasing solar interference. February pushes. 3, I beyond detection limits. 6 weeks to solve the greatest mystery in human history. 6 weeks to determine whether we live alone in galaxy or under observation by superior intelligence. 6 weeks to choose between natural universe assumption and artificial contact preparation. The Sunward jet phenomenon started this investigation. Impossible dust flows, physics-defying behavior. Evidence that something fundamental about 3 I defies explanation, natural explanations, strain credibility, cosmic ray surface processing over billions of years. Thermal decomposition of organic compounds, low-velocity particle ejection, synchronized timing with solar heating, possible but unlikely, too many coincidences, too many anomalies, too perfect trajectory, too convenient timing. Artificial explanations demand acceptance of intelligence beyond Earth, technology beyond human capability, observation beyond detection, contact beyond preparation, uncomfortable but consistent. Single hypothesis explains multiple anomalies. Occam's razor supports artificial origin despite psychological resistance. The choice seems obvious. Evidence points toward technology. Logic supports artificial conclusion. Science demands hypothesis that explains observations, but consequences terrify policymakers. Public panic potential. Religious upheaval, economic disruption, social instability, political chaos. Truth becomes secondary to stability. Evidence becomes subordinate to comfort. Science becomes servant to politics, which explains classification delays, analysis paralysis, peer review stalling. Publication postponement. The answers exist in government databases. 3, iData waits in computer memory. Truth sits in classified files, but truth release requires courage, leadership, vision, acceptance of cosmic reality, qualities in short supply among current decision makers. So we wait, watch December observations, analyze available data, build incomplete theories, hope for eventual revelation. While 3, I accelerates toward interstellar space, carrying secrets that could change human civilization forever. The Sunward jet streams behind it like cosmic breadcrumb trail, evidence of something beyond natural explanation, proof that universe contains phenomena outside current understanding. Whether natural breakthrough or artificial contact, the implications reshape human future. We stand at crossroads between terrestrial isolation and cosmic awareness, between natural universe assumption and technological civilization, reality, between comfortable ignorance and uncomfortable truth. 3, iAtlas, forces the choice whether we want to make it or not. Xavier Perez Cudo at University of A Coruña traces the trajectory backward 10 million years. Gaia Space Observatory data on billions of stars, precise positions, stellar motions, gravitational interactions over cosmic time. The search covers 100 million astronomical units from our solar system, looking for parent star, origin point, gravitational nudges that sent 3I toward us. They find 93 possible encounters, 62 when uncertainty is considered, but all happen too fast. Stars too distant, gravitational influence too weak, no smoking gun. 3, I emerges from galactic background without clear origin, like a cosmic ghost materializing from nowhere. The vertical velocity component tells different story. 18.5 kilometers per second above galactic plane. High speed perpendicular to galaxy disk, suggests thick disk population, older stars, different chemistry. Thick disk objects formed when galaxy was young, 9 to 13 billion years ago, cosmic noon period. Peak star formation, heavy element synthesis, planet building materials. If 3, I originated during cosmic noon, it predates our solar system by 4 billion years, ancient beyond imagination, cosmic relic from galaxy's youth. This changes everything about surface processing timeline. 4 billion extra years of cosmic ray bombardment, 4 billion years of interstellar chemistry, 4 billion years of organic molecule synthesis, surface layers thicker, chemistry more complex, behavior more exotic. Ancient surface accumulation explains unusual emission properties. Billion-year buildup of organic compounds, metal enrichment from cosmic ray spallation, complex chemistry from radiation processing, solar heating triggers, decomposition cascade, chemical breakdown, volatile release, mass loss, consistent with observed rates. But ancient processing also explains isotope signatures. Galactic chemical evolution changes heavy element ratios over time. Ancient objects show different compositions. Cosmic fingerprints of formation, epoch. Webb telescope isotope measurements become crucial. Carbon-nitrogen-oxygen ratios. Heavy element abundances. Age dating through nuclear archaeology. If 3, I shows ancient galactic signatures, natural origin, gains credibility. If 3, I shows recent solar system compositions, artificial manufacturing becomes likely. The stakes keep rising with each observation. September brightness surge coincides with increasing solar heating. Expected behavior for thermal activation system, natural or artificial, but brightness increase exceeds thermal models. More energy output than solar input alone provides, suggests additional energy sources. Internal energy generation mechanisms include nuclear decay heat from long-lived isotopes, accumulated over billion-year journey, provides background heating, chemical energy from exothermic decomposition reactions, organic breakdown releases heat, powers additional mass loss, creates positive feedback loops, gravitational potential energy from structural collapse, ancient materials reaching failure limits, catastrophic breakdown, energy release, or technology energy. From power systems, we do not understand. Each mechanism predicts different observational signatures. Nuclear heating shows steady exponential decline. Chemical heating shows temperature-dependent spikes. Gravitational collapse shows catastrophic events. Technology shows controlled energy management. Current observations suggest controlled rather than random energy release, steady mass loss rates, consistent emission patterns, managed rather than chaotic behavior. This supports technology hypothesis despite discomfort level. The trajectory analysis reveals additional anomalies. 3. I approach vector aims directly at inner solar system. Not random interstellar trajectory, not gravitational capture, deliberate targeting. Statistical probability for such precise aim approaches 0. Random objects show random approach angles. 3. I shows bullseye accuracy. Close planetary encounters compound the precision. Mars, October 3rd. Earth minimum distance, November. Jupiter gravitational window, December. Venus flyby, potential, January. Each encounter provides unique scientific opportunities. Atmospheric sampling, magnetosphere analysis, surface observation, gravitational assist options, perfect mission profile for systematic exploration, too perfect for coincidence. Either 3, I represents unprecedented lucky accident or designed exploration sequence. Mission design analysis supports artificial origin. Optimal energy collection through perihelion timing. Maximum solar heating when hidden from Earth observation. Peak activity during communication, blackout. Systematic planetary survey sequence. Mars atmosphere, Earth biosphere, Jupiter magnetosphere, Venus surface. Complete environmental catalog. Gravitational assist opportunities for trajectory modification, course corrections, mission extension options, return journey possibilities. Everything about 3. My trajectory suggests intentional design rather than random arrival. But intentional design implies intelligence. Intelligence implies civilization. Civilization implies contact consequences we may not survive. The dark forest hypothesis haunts every analysis. Galaxy filled with civilizations hiding from each other. First contact equals death sentence. Survival requires stealth. Discovery means elimination. If 3, I represents probe from dark forest civilization, we face existential threat. Reconnaissance precedes invasion, intelligence gathering precedes attack, contact precedes extinction. Military analysts study 3I capabilities. Velocity suggests advanced propulsion. Trajectory control implies sophisticated navigation. Emission properties indicate power generation, all consistent with military reconnaissance platform. Threat assessment mission, intelligence collection for future operations. Defensive preparations begin in classified programs, space-based early warning systems, planetary shield development, international cooperation protocols, but defense against interstellar technology may prove impossible. Physics advantages measured in centuries. Energy resources beyond solar system scale, technology gaps unbridgeable. Our only hope lies in benevolent intentions, scientific curiosity rather than military conquest, peaceful exploration rather than hostile reconnaissance. The Sunward jet phenomenon provides key evidence for intentions. Military systems minimize signatures, stealth technology, emission control, detection avoidance. 3, I does opposite, bright emissions, distinctive behavior, attention-getting anomalies, maximum visibility rather than stealth. This suggests scientific rather than military mission. Open exploration rather than covert reconnaissance. Peaceful intentions rather than hostile preparation. Unless reverse psychology applies, obvious probe masks, true surveillance, attention distraction from real intelligence gathering, theater for deception purposes. The uncertainty drives policymakers toward worst-case preparations while hoping for best-case outcomes. December, observation window becomes make or break moment for human future. Webb telescope locks onto 3i thermal signature, temperature mapping, energy source identification, internal versus external heating discrimination. If 3i shows thermal balance consistent with solar heating, natural origin remains possible. Ancient comet hypothesis survives. Human isolation continues. If 3i generates excess thermal energy, artificial origin becomes certain. Technology confirmation achieved. Contact protocols activate. Hubble continues ultraviolet monitoring. Gas emission chemistry. Molecular composition changes. Isotope abundance measurements. Solar system isotopes versus interstellar signatures. Recent formation versus ancient processing. Natural versus artificial manufacturing. Ground-based networks monitor radio frequencies. Artificial signal detection. Communication attempts. Electronic signatures, technology fingerprints. Any electromagnetic emission beyond natural plasma suggests artificial systems. Confirms technology hypothesis. Triggers first contact procedures. The next 6 weeks determine human future direction. Continued terrestrial focus versus cosmic perspective shift. Natural universe versus technological galaxy. Isolation versus contact. 3i Atlas forces choices we hope to avoid for centuries more. The dust continues streaming sunward. 20 meters per second against radiation pressure, physics defying, logic challenging, reality altering. Each particle carries message. We struggle to decode, natural or artificial, ancient or recent, benevolent or hostile. The answer rides sunward with 3i towards solar conjunction, hidden behind star, approaching peak activity, maximum revelation potential. When 3i emerges in December, it will tell us who we are in cosmic context, alone or observed. Unique or common, safe or threatened, the Sunward jet holds our future. Streaming away from 3i towards solar disk, carrying secrets that will reshape human civilization. In billion-year surface layer accumulated from cosmic ray bombardment, or in technology systems activated by solar heating. Natural ancient chemistry or artificial intelligence awakening, the distinction defines human destiny. 3i approaches perihelion. October 29th, peak solar heating, maximum system activation, final revelation, behind solar disk. Hidden from observation. Perfect timing for truth discovery when we cannot watch. But truth has way of emerging regardless of observation gaps. December will bring answers, natural or artificial, ancient or recent, peaceful or threatening. The Sunward jet streams towards solar conjunction carrying future of human species. Against physics, against common sense, against everything we thought we knew about universe. Toward truth, we may not be ready to accept. But, ready or not, truth approaches perihelion with 3i Atlas. Sunward, always sunward, into mystery that will define human future among stars.